Before we get started, this video in part is brought to you by PCBWay. If you're handy with a soldering iron, then consider using PCBWay for your next project. Great for students and hobbyists, PCBWay can supply all your custom PC board and prototyping needs. They also provide CNC machining and metal laser cutting services. Affordable prototyping and low volume manufacturing is at your hands. Or give your modeling projects a professional look with PCBWay's printed circuit boards of your own design. From 1 to 14 layers, empty or fully assembled boards, they can meet your needs. Fast turnaround times and competitive prices. Check them out at PCBWay.com. Look for more info in this video's description below. The GILMORE RACER is an all-wood kit covered in low-temperature film. The tail is completely built up for lightness and has a two-color scheme with black trim. CA hinges are used on all control surfaces. Wings have the same trim design and were also winkle-free. Servo mounts have pull strings for servo leads. The fuselage is impressive, with large fillets and accurate-looking ribs at the aft end. 2 nylon screws hold on the canopy hatch, which is balsa ply turtle deck with cockpit. Inside shows a well-engineered structure with ample room for equipment. I'll admit, it has a certain beauty to it. Fuel tank area doubles as a place for electric power batteries. Fiberglass cowl has valve rocker blister details molded in and red trim pre-applied. Stiffness seemed good with a thick weave. I should note that the cowl is huge. Okay, anyway, there's also a dummy engine insert made of fiberglass. It helps fill the void in that big face. More fiberglass, this time in the form of these snazzy wheel pants. Some fairly intricate construction, I'd say. Metal landing gear struts take the real load and are quite stout. Wheels are a sort of foam rubber hybrid, best I could tell, measuring at about 5 inches in diameter. If you choose to use an electric motor, an adjustable link motor mount is included. As expected, there is a multitude of small parts in a kit. A fuel tank that I would guess is around 16 ounces. And a decal sheet with some rather large stenciling. Manual is typical of Seagull models with lots of black and white photos that's generally pretty easy to follow. Alright, so assembly starts with the gluing of the aileron hinges in place with thin CA. Then epoxying the control horns after roughening up the surface a bit. While I was at it, I mounted the elevator horns as well. Back to the wings, it was time to mount the aileron servos. I'll have to say, I was really impressed on how well the servo mounts were glued together. The high-tech 645 servos fit right in, though the servo arm was almost too tall. After mounting the servo, the included pull strings can be utilized. Control linkages are then snapped on, and ailerons are done. I'll add the silicone tubing later. Diverting to the fuselage. I needed to open up the servo holes slightly, in order to fit the servos into the respective locations. On the bottom, I can now install the landing gear, which is mounted with 3mm screws after applying thread lock. The 2 outer screws also hold the eyelets for the guide wires, which will be attached later. The fiberglass wheel pants have 2 holes for mounting screws, but the screw holes were not drilled into the landing gear. This means I'll have to drill and tap my own holes. Before I could do that, I would need to mount the wheels, so start with the axles. I test fit the wheel pans with the wheels installed. This gave me an idea of how things should look. This showed that the screw holes should be centered on the gear, so I measured and drew a center line. With the pants back on, the holes matched the center line. Then I made a drill mark with a pin vise. Then an automatic center punch I almost forgot I had. Now I can drill and tap the holes. Yep, looks good so far. Time to reassemble everything and screw in the wheel pants. Yep, work like a charm. The engine I'll be using is the same Stinger 35 from my ill-fated Cessna Caravan. The rear exhaust model survived the crash like the stud it is. Anyways, there's a neat slide-in column mount ring that screws in. The kit includes a snazzy engine mount drilling guide with multiple engine and motor references. A quick hole spacing measurement showed I could use the DLE 30 markings. The guide slips onto the front of the motor box and is self-aligning. I really like this design. It is nearly foolproof except for especially talented fools. Guide holes are then enlarged for the blind nuts. Holes in the fiberglass reinforcement are deburred with a large drill bit. Now it's time to test fit the engine. Blind nuts can now be inserted and tightened into place. Before I completely screwed them in, I placed a bit of epoxy under them. The manual helpfully gives the output shaft distance you need from the firewall, which is pretty close with the included standoffs. A thick washer will be used to make up to 2 mm shortfall. As I said, the included tank appears to be around 16 ounces, but that's a guesstimate. And it has a workable clunk. I got lazy and tried to bend the brass tubing by hand. Yeah, that wasn't a good idea.
Oops.
So I pulled out my tubing bender tool, which did a much better job. Why didn't I do that in the first place? The fuel tank mounts to a removable tray that can also be used for mounting the batteries in an electric version. There is then a throttle cable guide that must be glued in. I eyeballed the drill mark for the throttle cable pass-through. Yep, my eyeballs are still calibrated. As is tradition, I will set up a servo-controlled choke, which means I'll need to cut out a new servo slot after marking the location. That is quite satisfactory. Holes are then drilled for the fuel line and choke cable. Note that I offset the servos so they won't interfere with each other. Now to attack or prepare the dummy engine. The fiberglass is pretty thick, so I'll need to drill some pilot holes first. And carefully connect the holes with a cutting tool. Edges are then cleaned up with a small drum sander, with a final touch-up with some hand sanding. It's a bit of work, but the final results are quite nice, and will have plenty of cooling. Valve pushrod details can now be added. Medium CA is used to hold them in place. The results are workable. The whole assembly is then hot glued into place. Be sure to align an opening with the cylinder head before gluing. Scrap cardstock is used to make a drill guide template for the cowl screws. A pinhole is made first without the cowl, then used to mark the drill location on the mounted cowl. And drill. Easy as 1, 2, 3. Before mounting the horizontal stab, I drew some center lines. This helped align the stab, which I temporarily pinned in place. While I marked where to remove the covering. Which I did with a covering iron. Some good old 30-minute epoxy is then used for glue. When cured, the vertical stab is next. We now move on to the tail control rods. Piece of cake. There are a lot of guide wires to assemble, so get a comfy chair. Note that the wires are different lengths, so be careful which one you use for where. Each clevis attachment must be assembled. I can build these things in my sleep now. The first set are actually pull cables for the rudder. And speaking of rudder, the tail wheel assembly starts by mounting a T-bracket to the bottom. Then the wheel assembly to the fuselage. Tension springs will need to be installed. Fortunately, after assembly, I realized I had the wheel on backwards. But it was an easy fix. 3mm screws are inserted through the stabilizer for the guide wire eyelets. Not every eyelet uses a clevis. I'll tighten up everything later. Now to do the wings. A single Jesus screw holds the wing on from the bottom. Though one side was slightly misaligned, so I drilled it out to a slightly larger hole. Much better. So we continue on with a multitude of eyelets and guide wires. It does look pretty good when done. All wired up, I added the ignition module. Note the foam rubber under the module to help prevent failures due to vibration. I thought the included pilot figure was pretty good. The manual says to glue the canopy on, but I prefer to screw it on. For this, I like to use some really small screws from RTL Fasteners. Look for more information and discounts for them in the video description. After aligning the canopy, holes are drilled for the screws. Then screw away. Note, after making the holes, I use thin CA to reinforce the wood. I then grab some more cardstock. Why, you say? Well, to make a drill template for my switch panel. That's right, I got all fancy with the GILMORE. It even has a refueler port. My top hatch is a bit tight and it took some careful technique to get it on. And a plane is born. Well, wait, something's missing. Decals! Some of the library can be quite big, but everything goes on easily. I didn't feel the need to use water. Strangely, the right wing decal had alignment marks that needed to be trimmed away. With that, join me next time when we take to the air, old-timey style. Oh, and one last thing before I go. I just wanted to remind everyone to please take a look at the channel sponsors and supporters in this video's description. There are quite a few discounts associated with this channel that you may find useful.